everyone, we're going to go over section 11.6, and in this section we're going to work with events that involve not or, not and or. So the probability of an event not occurring. So the complement of E, or the complement of an event, if we know the probability of an event, the probability of an event E, we can determine the probability that the event will not occur denoted by the probability of not E. The probability that an event will not occur is equal to also 1 minus the probability that it will occur. So the probability of not happening is equal to 1 minus the probability of occurring or happening. The probability that an event will occur is equal to 1 minus the probability that it will not occur. So anyway, something that I like for you to, maybe it might be easier to remember. This is a notation here. So that's the notation for complement. But some authors prefer to use the E with a bar. So either one of those two. You might see E with a bar with another author. I just wanted to show you that there is another way that different authors have decided to express complement. So an example that I'm going to mention before we do this is if you know that the probability that it will rain is equal to 40%, if somebody asks you what is the probability that it will not rain, you will say, well, okay, it's 60%, and you do that very quickly. In your head you will say, well, okay, they have to add up to 100%. So that is basically what they're telling you here. So if the probability that it will not rain is equal to 1 minus the probability that it will rain, and the probability that it will rain, if you know the probability that it will not rain, is 1 minus the probability that it will not rain. So hopefully that helps you in understanding this section about complements, that part. So example 1, we're working with a standard deck of cards. So remember that I recommend that you have this with you while you're testing and doing the homework. So if you are dealt one card from a standard 52 card deck, find the probability that you are not dealt a queen. So remember that there are 52 cards. So not a queen, we have 1, 2, 3, there are 4 queens. So it says, what is the probability that you are not dealt a queen? So there is more than one way of doing this. So the probability that is not a queen, I'm going to use the concept of complement. It's the same thing as 1 minus the probability of getting queens. So this is going to be 1 minus. So the probability of getting a queen from the 52 deck of cards is 4 out of 52. So 1 minus the 4 to choose from out of 52 will be the probability of not getting queens. And you can also could have done this by taking 4 away from 52, and you will say that that is 48 out of 52, and simplify the fraction. So I'm going to show you how to answer as a simplified fraction. So here we're going to enter 1 minus, and I like to enclose a fraction in parentheses just to be clear on what you are subtracting. So it's 1 minus 4 out of 52. So I'm getting a decimal again. So if it's not asking you to answer in decimal form, then you press math, enter, and it will be the simplified fraction is 12 out of 13. So if you will have preferred, I'm going to show you another way of doing this. You can say, oh, well, not queen, the probability that is not queen, not a queen, you could have done this 52 minus 4 and then divided by 52. Okay, and because there are 4 that are queen out of the 52, so if you remove the 4 from the 52 deck of cards, you will get the ones that are not queens. So I will demonstrate to you that 52 minus 4, that gives you that number, divided by 52. It gives you that decimal, math, enter. Notice that we arrived at to the same answer. So it doesn't matter how do you decide to approach the question. The best method I always say that is the one that makes more sense to you, that you will remember in an assessment to apply the skills. So it's really, they're both the same. But it's good to be familiar with the complement, the concept of complement, because it will really help you in cases that you don't have all the information and you need to use a complement. So I will try to emphasize the complement as much as I can. Example 2 is also with the 52, a standard 52 deck of cards. It says find the probability that you are not dealt club suit. So the probability that is not a club suit. And in case you forgot, it's like, what was that again? Okay, so here it is. The clubs are these ones, and there are, as I mentioned here, 13 clubs. So it says, okay, you're not getting this 13. So I can use a complement and say, okay, 52 minus the ones that I don't want will give me the ones that they're asking me to find. So that will be going direct. So I can say, okay, 52 minus, in this case, 13 that are clubs divided by 52 will give me the answer. So I'll enter that in the calculator. And again, that one will be, that method is without using the concept of complement. So 52 minus 13, and again, I like to enclose it in parentheses, divided by 52, and then we press math, enter, enter. So that will be 3/4. If I were to use a complement, the probability that is not a club, since they both have to add up to 1, being a club and not being a club, they have to add up to 1 to amount to the 100% probability. So 1 minus the probability of being a club. So this is going to be 1 minus their 13 clubs out of 52. So again, the calculator will help you with the fractions, because I know the fractions, they tend to raise your blood pressure. So if you're allergic to fractions, then learn how to use a calculator to help you in the moment of need. So that gives you the same answer, 3/4. So again, the best method is the one that you remember to use when you have to use it, especially in an assessment. So next, now we're working with OR probabilities with mutually exclusive events. Mutually exclusive events are the events that are impossible to occur simultaneously. So in English, what that means that they cannot happen at the same time, or in Spanglish, I'll say. So the OR probabilities with mutually exclusive events, they're going to use this formula. That is when they do not overlap. So mutually exclusive events, they don't overlap. No overlap. They have no outcomes in common. And if you want to use the set notation, the probability of A union B is the probability of A plus the probability of B. And remember, this was at the beginning of the semester. Remember that this means union is the same thing as OR. So, number 3, example 3. If one card is randomly selected from a deck of cards, what is the probability of selecting a king or a queen? A king and then or. Or must always inspire you to add. So if it is an or, we're adding the probability of king plus the probability of queen. So you go back to the standard deck of cards, and kings, we have 1, 2, 3, 4. You have 4 kings to choose from. So we're going to write in here 4 out of 52. And then queens, you have 1, 2, 3, 4. So queens plus 4 out of 52. Since they have the same denominator, I keep the denominator the same. Add across 4 plus 4. This gives me 8 out of 52. Enter this in Dora de Calculadora, or Diego wants to help us now. So we can enter this in the calculator as 8 divided by 52. And we press enter. And if we want to express this as a decimal, if you look at this key here in this calculator, here it says table, but it's FD, so fraction to decimal both ways. That will be converted to a decimal. See if Diego doesn't want to cooperate. Okay, so I have to press the green button in this calculator, and Diego is not being nice to me. Okay, so let me enter it as a fraction. Let me try entering this as a fraction. Come on, Diego. A divided by 52. Well, let me see if I enter this as a fraction. Let's see what happens. Okay, so if you use this fraction key in here, it will give you the simplified form, 2 out of 13. So this is 2 out of 13. Next, you randomly select one card. So every time you see that, it's like, there we go again with the deck of cards. So it says, find the probability of selecting 2 diamonds or the ace of clubs. What is the probability of the 2? This should say 2 of diamonds. 2 of diamonds. Or the ace of clubs. Ace of, I'm not good at drawing this. Ace of clubs. Okay. So this should, So this should be the 2 of diamonds. So you go to the diamonds, and there is only one that is the 2 of diamonds. And the ace of clubs, there is only one of each. So 1 out of how many? 1 out of 52 plus 1 out of 52. So this is going to be, keep the denominator the same, you add across, simplify the fraction. They're both divisible by 2, so you can use a calculator or divide them both, numerator by 2, denominator by 2, and that's how you will simplify by hand, because they're both even numbers. So those examples 3 and 4 are examples of questions that are mutually exclusive. So what that means is that they do not occur. You don't have a card that is a 2 of clubs or a 2 of diamonds or ace of clubs that it has both. It's only one of each. So now in the next examples, we're going to work with the ones that are not mutually exclusive. So again, what that means is that they overlap. They overlap. So the formula is different. If they overlap, we have to remove the overlap. Okay, so these are the formulas that we're going to use because they overlap, they occur at the same time or simultaneously. So let's look at this example here. This should be actually example 5. So the math department has 8 male professors, 6 female professors, 9 male teaching assistants, 8 female teaching assistants, and 8 female teaching assistants. If a person is selected at random from the group, find the probability that the selected person is a teaching assistant or a female. So I like to give it a name. So the probability that is a TA, and then it says or a female. So this is the probability of being a TA plus the probability of being female minus the probability of being a TA and female. So the probability of being a TA, so it says the math department has 8 male professors. They have 6 female professors. They have 9 teaching assistants and 8. Oh, these are male teaching assistants and these are female teaching assistants. So the total, we need to know the denominator because they're asking us for probabilities. So we need to know the denominator. So the denominator will be the sum of all of these. So this is going to be 8 plus 6 plus 9 plus 8. So that gives me 31. So the probability of being a teaching assistants are these 2 are teaching assistants. So that is 17. So that's where the 17 comes from. The probability of being female, you can be female and you can be a TA female. So it will be adding these 2 numbers, that will be 14. But notice that I'm using this TA and female twice. That's why we have to remove the overlap. So this is going to be 14 out of 31. So now I have to remove this one that it is both, and I have used that amount twice, 8 out of 31. So again, my denominator will be 31, and I just add across 17 plus 14 minus 8 will become my numerator of 23. And if I'm interested in simplifying that, I can try to simplify 23 divided by 31 using the fraction symbol, and it cannot be simplified any further. So let me erase this so it looks like a proper final answer. So the answer is a fraction 23 over 31. And these are the last two examples for this section. The table shows the educational attainment of the population of Mars, age 25 and over, expressed in millions. Find the probability that a randomly selected Martian, age 25 and over, has completed 4 years of high school only, or is a female. So the one that has completed 4 years of high school only, years of high school 4 only is this. So that means 45 out of the total of 49. So this will be 45 out of 149. That is the 4 years of high school only. And then probability of being a male, the total for males is 78 out of 149. Minus the overlap of male and 4 years of high school only, 23 out of 149, because we use that number twice. So this will be 45 plus 78 minus 23 divided by 149. So it gives me a decimal. Let me see if the fraction to decimal will like to work now. Okay, it decided to work. So this is going to be 100 over 149. When you do the simplified fraction, it will be 100 over 149, the simplified fraction. And again, they may ask you for a decimal, and I am answering everything. We usually feel comfortable converting fractions into decimals, so that's why I'm emphasizing simplifying the fractions. Example 5. A student is selected at random from a group of 200 students in which 135 takes math, 85 takes English, and 65 take both math and English. Find the probability that the selected student takes math or English. So in order to get this one, it will be the probability of math plus the probability of English minus the probability of math and English. So the probability of math, it says 200 students, so that will be my denominator. I don't have to worry about finding the denominator. They tell you that there were 200 students. So a student is selected at random from a group of 200 in which 135 they take math. So that will be my numerator. 85 take English and 65 takes both. So we can enter the denominator for all that, since it is the same, is 200. So all I have to do is add across 135 plus 85 minus 65. And that gives you 155. That will be my numerator. Divided by 200. And I will be converting this to a simplified fraction. So that gives you 31 divided by 40. My final answer, 31 divided by 40. Okay, so that's it for this section. I hope you were able to understand. Remember that you can always rewind the videotape, pause it to help you with the digestion of the information. Thank you so much for your time today.